Ragdoll physics is a type of physics engine procedural animation which is often used as a replacement for traditional static death animations in video games and animated films. Introduction. Early video games used manually created animations for characters' death sequences. This had the advantage of low CPU utilization, as the data needed to animate a «dying» character was chosen from a set number of pre-drawn frames. As computers increased in power, it became possible to do limited real-time physical simulations. A ragdoll is, therefore, a collection of multiple rigid bodies, each of which is ordinarily tied to a bone in the graphics engine's skeletal animation system, tied together by a system of constraints that restrict how the bones may move relative to each other. When the character dies, their body begins to collapse to the ground, honoring these restrictions on each of the joints' motion, which often looks more realistic. The term ragdoll comes from the problem that the articulated systems, due to the limits of the solvers used, tend to have little or zero joint, skeletal muscle stiffness, leading to a character collapsing much like a toy rag doll, often into comically improbable or compromising positions. The Jurassic Park licensed game Jurassic Park: Trespasser exhibited ragdoll physics in 1998 but received very polarized opinions. Most were negative, as the game had a large number of bugs. It was remembered, however, for being a pioneer in video game physics. Modern use of ragdoll physics goes beyond death sequences. There are fighting games where the player controls one part of the body of the fighter and the rest follows along, such as Rag Doll Kung Fu, and even racing games such as the Flatout series. Recent procedural animation technologies, such as those found in Natural Motion's Euphoria software, have allowed the development of games that rely heavily on the suspension of disbelief facilitated by realistic whole-body muscle, nervous ragdoll physics as an integral part of the immersive gaming experience, as opposed to the antiquated use of canned animation techniques. This is seen in Grand Theft Auto 4, Grand Theft Auto 5, Red Dead Redemption, and Max Payne 3, as well as titles such as LucasArts' Star Wars, The Force Unleashed and Puppet Army Factions Control, which feature 2D-powered ragdoll locomotion on uneven or moving surfaces. Approaches. Ragdolls have been implemented using Featherstone's algorithm and spring damper contacts. An alternative approach uses constraint solvers and idealized contacts. While the constrained rigid body approach to ragdolls is the most common, other pseudo-ragdoll techniques have been used. Verlet integration, used by Hitman, codename 47 and popularized by Thomas Jakobsen, this technique models each character bone as a point connected to an arbitrary number of other points via simple constraints. Verlet constraints are much simpler and faster to solve than most of those in a fully modeled rigid body system, resulting in much less CPU consumption for characters. Inverse kinematics post-processing, used in Halo, Combat Evolved and Half-Life, this technique relies on playing a preset death animation and then using inverse kinematics to force the character into a possible position after the animation has completed. This means that, during an animation, a character could wind up clipping through world geometry, but after it has come to rest, all of its bones will be in valid space. Blended ragdoll – this technique was used in Halo 2, Halo 3, Call of Duty 4, Modern Warfare, Left 4 Dead, Medal of Honor, Airborne, and Uncharted – Drake's Fortune. It works by playing a pre-made animation, but constraining the output of that animation to what a physical system would allow. This helps alleviate the ragdoll feeling of characters suddenly going limp, offering correct environmental interaction as well. This requires both animation processing and physics processing, thus making it even slower than traditional ragdoll alone, though the benefits of the extra realism seem to overshadow the reduction in processing speed. Occasionally the ragdolling player model will appear to stretch out and spin around in multiple directions, as though the character were made of rubber. This erratic behavior has been observed to occur in games that use certain versions of the Havok engine, such as Halo 2 and Fable 2. Procedural animation, traditionally used in non-real-time media film, TV, etc., this technique used in the Medal of Honor series starting from European Assault onward employs the use of multi-layered physical models in non-playing characters, bones, muscle, nervous systems, and deformable scenic elements from simulated materials in vehicles, etc. By removing the use of pre-made animation, each reaction seen by the player is unique, whilst still deterministic. See also: Cartoon physics, Joint constraints, Stair dismount, Truck dismount, Lugaru.